Hello, I'm Samuli Jääskeläinen. I'm from Mindfield Games. We are a Finnish virtual reality startup, and we are currently doing our first project, Pollen, which is a first-person virtual reality exploration game. If you have been reading Unity's blog, they recently blogged about our game, about all the features of Unity 5 that we are using. So if you are interested in the high-end features of Unity 5, you should check out the blog. And in a few weeks we will be showing the first gameplay from our game in GDC and PAX. But here I'm going to talk about a little bit how to use virtual reality devices with the Unity and what you need to keep in mind in the technical terms to be able to use them in Unity. And how many of you have used Oculus Rift DK2 or DK1? Yeah, it's a normal percentages in these kind of groups. And I will go through a few popular HMDs, head-mounted displays, as they are called, that are currently available for Unity. So the most popular currently, of course, is Oculus Rift DK2, which requires a dedicated computer, so it's for the desktop VR. And I wouldn't recommend using laptops because there is no such thing as a powerful enough laptop to run high-end games with DK2. It has a rotational tracking, so it will track your head movements. You can rotate your head in the 3D scene. It has a positional tracking, so you can crouch and move around in the 3D scene. And its SDK is provided by Oculus, and it works with Unity 4 and 5, and recently Unity updated it to be a free version, so even though it's using render targets, Unity 3 can also use it in both 4 and upcoming 5. And in the future, Oculus Rift will be a target platform in Unity, so it's not just a plugin, it will be integrated into Unity itself. And then there is another just launched device, Samsung Gear VR, which is a cooperation between Samsung and Oculus, which requires Note 4. So it's a mobile headset. You put this mobile phone into the headset, and the headset handles rotational tracking and all kind of other powerful stuff that is not implemented in the phone itself. It doesn't have a positional tracking, it only has the rotational tracking, because positional tracking, like crouching and stuff, requires external camera, and you don't usually carry external cameras around with you if you're using a mobile phone. So SDK is provided by Oculus, and it also works with Unity 4 and 3. Support for Unity 5 is coming at some point, and it will be also a target platform. We don't still know if there will be a VR virtual reality target platform, or is it just different for the Gear VR and Oculus Rift. But their SDKs are pretty much same if you use them. Then there is the cheap version, Google Cardboard, which works with any Android phone, basically. And it requires some kind of smartphone, so those old Nokia bricks won't work, but if you have something like Samsung Galaxy S2 or 3, those kind of older phones also work. But it relies on the phone's acceleration and gyrometer, so it doesn't have any built-in gyrometers, so it will drift very badly. So if you start the game looking in this direction, after half an hour, your forward direction might be there or there or there. So it's really bad for extended use. But if you want to look, for example, 360 photographs that wrap around your head, or 360 videos that's wrapping around your head, it's good for previewing that kind of content. But for gaming, it's pretty much no-go. And its SDK is by Google. It's extremely simple to use, and it works with Unity 4 and with 3, but it has some limitations because it can't use render targets. So when you are looking through the lenses to the phone, it can't wrap the image. So it will be a little bit distorted if you're using with Unity 3. And I'm not sure if it works with 5, it might or might not. And then there is Sony Morpheus, which is HMD, which is coming from Sony for PlayStation 4. It has a rotational positional tracking just like DK2. And its SDK is by Sony, but it's not public. But if you have the Morpheus as a developer, you can use the Unity plugin that they offer, which I've heard is really similar to Oculus Rift DK2's Oculus plugin. So it's kind of like very easy to set up. There is this one post-mortem by one guy who pretty much said that it will take like 1 day to set up if you have a VR setup for any other device. So it's kind of easy to go into console VR also. Then there is also numerous of like not very viable products at the moment because the VR is booming and going like big and big and big, so everyone is trying to get the piece of cake, but these are the major players. And what I've heard, it works with 4 and 5, but I don't know if it requires Pro, but I would suspect that you already use a Pro license if you are doing for PlayStation 4. Okay, so let's go inside Unity. But I'm not actually going to go inside Unity, but I'm just showing you some more slides. Because the hardware is in beta. Like all these devices are currently in heavily in work in progress. So there is no point of like saying this is final, this is final, this is final. And more importantly, the software is in beta. I have rewritten the support for Oculus Rift like 3 times for Pollen or something, because the SDK is changing so rapidly. And if I would now show how to integrate Oculus Rift DK2 into your project, it would be obsolete in 2 or 3 months. So I don't think it's like there is no any point, and it's really easy to set up. So if you can read documentation, you can set up it in a few hours. And then also Unity is in beta, so they will have the target platform for VR. So we don't know how it will work. So it will be coming soon, and it's good to wait for that. And then also the current state of having these cardboard SDKs, mobile SDKs, desktop SDKs, they conflict. So you need to be very careful when you're putting them into the project that, okay, this part of the project is for the mobile and this is for that and this is for that. Otherwise, you just can't build it. So there is something I can show you from inside Unity, which is the camera management, because this won't change, even though the APIs and all kind of plugins and how do they build and work will change. The camera management will be pretty much this setup because it's the only way to do it. So you have 1 camera per eye, so you have 2 cameras in UC. Then you have a center point, which will rotate and move the position of the eyes. So in the hierarchy, we have a player, and then we have 2 cameras. We have a normal camera, which is for normal displays, and usually you just disable it if you're using it for VR. And then we have the VR rig, where we have 2 cameras. And then Oculus also has a center eye anchor. So this is the rig, which is using the rotational and positional tracking. And the center eye is actually calculated, because your eyes are a little bit further away from the pivot point of your head. The center point is actually between your eyes, not in your head. So there is this like 3rd eye, which is useful for raycasting and stuff like that. And then, because you have 2 cameras, and then you maybe have your normal camera if you are also supporting non-VR players, you need to have some kind of effect handling. So if you have 3 cameras and they all need to have same like post-processing effects, you should make some kind of custom effect handling for that. We didn't have that for Pollen for like half a year, and it's always pain in the ass to see like, oh, I don't have this effect in my right eye, but I have this effect in my left eye, and it just looks funny and it's hard to debug. So make it when you make the system work. And then this is something what will change. Oculus have said that the current way of doing it is quite bad, but if you have a near and far setup, so if you are making a space game, you might have a near camera for the cockpit and a far camera for the space. So you could render the space just once and copy it for the both eyes, because it's so far away that you can't see 3D. But you can see 3D in the near space, so you need to render 3D in the near camera. So currently you would actually need to put 2 of these kind of rigs in the scene and layer them manually by yourself by layering the cameras and rendering others only through depth. Which is useful, but like you will get a lot of cameras in the scene and it's pain in the ass to handle. So they said that they will do something about it, I don't know what. But that's the current way of doing it. And then I will briefly talk about some rendering stuff that when you are making this kind of VR game, what you should think when you are trying to make your 3D scene. Because obviously you can't make like normal regular 2D games, and even most of the current 3D games use so much tricks to do their 3D that they don't actually look 3D when you put Oculus Rift on your head. So first of all, billboards and sprites will look billboards and sprites. So for example, for Poland we have this custom foliage system which use particles for rendering all kind of vegetation. So there you can like actually see the leaves from all around your like all around the leaves, and because it's a particle system, it's really cheap to render. And you could also use this as an artistic choice. So there is a couple of games that actually use sprites and they still look okay. So for example, Doom is converted into virtual reality, and it looks really funny because you're shooting these cardboard guys. But if you use that as an art style, it will work. But if you are trying to do this kind of realistic stuff, just try to avoid them as much as you can. Same goes for decals. So if you have a decal on the wall, like painting, if you just like have it 1 millimeter from the wall, you can actually see it levitating. So you need to do some kind of deferred decals that you project in the wall. Then for normal maps, the same thing goes. Like normal maps look flat, they are just wallpaper, they don't work. But if the detail is small enough, so for example this is here is a little bit of medicine, and it's really small in the games, like something like this. So these bumps here and these like edges here are normal mapped, but as you can see, even these like little concave shapes here are actually modeled in 3D. So you need to be careful of where you draw the line of what works with normal map and what doesn't. So always just test the assets in Oculus Rift and again and again and again and see where it works. Currently in Poland there is quite a lot of normal maps that we use, and most of them don't actually look that good in VR, but because we just can't render 10 million polygons all the time, we can render something like 5 million or 7 million. It's not enough for everything. As I said, test your graphics in 3D and with Oculus. Not only because of the depth perception, it's also because of the scale. Stuff look different scaling. So if we have this kind of low table in VR, it actually needs to feel like it's low and it's sized like this. So when we first put some like 3D rooms together with Oculus Rift, we could see like, okay, this wall is off a little bit, this door is too big or too small, or this mug is huge. We still have like one placeholder mug that is as big as a basketball or something. Of course, if you are really heavy coffee drinker, it might be good, but it's a bit overkill. So for artists, they need to also have their own devices, so they can check their models in Unity whenever they can, when they are making the actual models. Oh, and I also wanted to talk about UI here. So why I asked about shooting the rays in the 3D world is that you can't have a traditional UI stuck in your face. It just doesn't work with Unity. So with VR, you need to have a world space UI, and all the elements are actually casted in the world. So we have this highlight system, which is casted in the world. We have this icon that you can press stuff. It is actually a 3D mesh that is rendered in the world as a 3D mesh. So in the same way, if we are making menus, they actually need to be levitating in the scene, and we are using a virtual cursor that we made ourselves. But our menu system is a mess, so I would like to upgrade it to Unity. Unity's own menus if it's possible. Luckily we don't have much menus because it's just a first-person exploration game. And then there is a lot of other notable issues, like player shadow. Like we've been like thinking, should we have a player shadow or not? Sometimes it feels like really odd that you don't have a shadow, but it's really hassle to implement because you need to rig your whole character just to make a shadow. So it's easier if you also have a body. But usually, if you play like normal FPS games, you don't even think about shadows, but that's something with virtual reality. If everything looks realistic, you are missing your own shadow even. And then graphics pop-up is very noticeable, so if you have these billboard changes to 3D objects, they are like extremely noticeable. Usually they are on normal monitor also, but with VR it's even more. And then you have wider field of view and stereoscopic rendering. So it takes a lot of more horsepower to render scenes. So with current DK2 setup, it's something like 120 degrees of field of rendering. So you are always rendering a lot more of the scene than normally. And then player can look into any direction at any time. You never should force players' head movements because it feels like someone's like grabbing your head and like moving around, and that just doesn't feel really good. So when you are implementing cutscenes and stuff like that, you should always remember that player should be able to look around. So if you want to get the player's attention, you need to visually guide player to look in the right way, and then use audio clues also for player to look in the right way. And this also, like, usually if you make a menu scene in the game, you just don't put anything behind the camera. But now you need to have something the player can always look behind his back. This was like first VR game I ever done was for one game jam, and like 30 hours in we realized that we don't have anything behind the player. But luckily then we just copy pasted some environment there. And then the relation of body and head position. So you can reset the Oculus Rift or any other HMD to be like, this is your original position of playing. But then if I have a swivel chair, I might spin around and like go here. But this is still my original position. So our player might be here, our collisions might be here, but the player's head is actually here. And this might cause a lot of really interesting problems, and most of them are actually unsolved. So many people have really different ways of dealing with this situation. And we are currently investigating what is the best one. But we are basically planning to just like gradually move the head back, gradually move the player's body back where their head is. And also you should fade into black when your player puts their head on the wall or something where they can't put it. Because it feels really bad if you just stuck the camera in. Because then you're like, you are moving the head in the real world still, but like it's not moving in the game. So just let users put their head anywhere they want. Just fade it black if it's something where you don't want players to put their heads. And this can cause interesting issues because we have like these thin doors in our game. So you can actually put your head first in the door and then it's black, but when you go right like through the door, then you can look through the door. So you need to be careful. And then the resolution of the virtual reality devices are still quite low. They are getting higher and higher. Of course they are like a lot better than they were a few years ago, but they are still really low. So if you have any text in your game, try to avoid it or make it big, so it's easy to read. I have tried reading some visual novels using this kind of virtual desktop, and it's fine if you just put the text big enough. And the same goes for detailed objects in the horizontal. So if you have like a sniper game or something, it might be a really bad idea because you just can't see the enemies without the sniper. But this is the most important thing. You need to keep constant frame rate. You can't stop any frames. And as I said, we have wider field of view, 3D stereoscopic rendering. We have beta hardware, beta software, and even SDKs are beta. NVIDIA is soon releasing some kind of virtual reality drivers, but those virtual reality drivers will be in beta. So everything is kind of slow in the begin with, and then you need to have these crazy frame rates. So with Gear VR, with mobile VR, you need to have 60 frames with this phone without dropping any frames, and it is a quite quad HD resolution, so it's past full HD already, and it's my phone. This is crazy. This is the highest resolution device I own. Then we have the development kit 2 from Oculus, which is full HD. You need to keep 75 FPS. And for the consumer version, Oculus is aiming for 90 FPS. And you can't drop a frame. Which makes this game, which is using all the high-end features of Unity 5, a quite mess to optimize. But we've been okay so far. So we'll see what happens. Of course, when we first started Pollen, we thought this will be like DK1, which is 1280 by 800, which is and 60 FPS, so you can render anything in that. But now it's getting a bit harder. But this is something you should remember when you are starting to make your game, and this is the biggest technical hurdle and challenge, to maintain the constant frame rate without dropping any frames, because if you drop any frame, it's just like dropping a one frame in from your own world. So, thank you. Do you have any questions?
About the frame dropping, is there a solution like NVIDIA's G-Sync has been for like normal monitors where
there is this crazy stuff that John Carmack is doing, which is time warping, and with Gear VR they're using asynchronous time warping, and I would highly suggest reading about time warping if you are doing virtual reality development. It will be a big thing, and it's already a big thing. It basically like estimates your next frame and creates a depth information from old frame. So it moves your head around in the old scene. Because with this kind of G-Sync and stuff like that, you can't predict where the player is moving their head, which makes it harder to use. So we need new kind of text for the virtual reality. But they are researched. So as I said, everything is beta, so it will take a few years for software to be really optimized.
Can we get you talking again after the consumer version is released, so we get to see hands-on how it works in Unity actually?
Yes, not a problem.